All right, guys, so we're going to continue practicing this and we're going to talk about a way that we can go through and we can check to see if our expressions are equivalent. So we can substitute a value for each variable that we have so we can check to see if our expressions are equivalent. So let's go ahead and start through this process and see how we can work through things to determine what's going on. So as we look at this first question right here, the first thing I check to see if I can do is if I can distribute anything. So right now, at first, it appears that there is nothing that I can distribute. But the actual truth is the fact that I have this negative right here that's outside of my parentheses, and I can go ahead and distribute that negative. So I'm going to do the distributive property really quickly, and I'm going to distribute that negative. So this is the justification for my step. So I'm going to distribute that negative to whatever is inside of these parentheses. So I get a negative 3x. And then, so remember the negative makes everything on the inside the opposite. So this is going to become a negative 2, right? Then I have my 4x plus my 2y minus my 10. Now the next step that I can do is that I can use the commutative property. Not the commutative property. I'm going to use my associative property to go ahead and just kind of start regrouping or figuring out how I want them to associate with people. So the associative property, right? So I can regroup things. I'm going to go negative 3x plus 4x. I'm combining those like terms. So the negative 3x and the 4x. Now I have a negative 2 here, and I have a negative 10 here. And then I have this 2y that's kind of all by itself, and it was a positive. So I'm going to put that 2y right there just so I can see that. Right, so now I have a situation here where I can now combine like terms. So I'm going to combine like terms. And I'm going to say a negative 3x plus 4x is just going to give me an x. And then I'm going to get minus a negative 2 minus 10 is going to give me a negative 12. And then I'm going to get a 2y. Now, typically when we write these, when you start seeing mathematically, the mathematically mannerly way to write them is to put the whole number without any variable at the end. So we could rewrite this in that format to be able to do that. So we can write that in a different order using the associative property. So the idea of checking suggests that we can take any number, and let's say I'm going to say that x is going to equal 2 and that y is going to equal 1. I want to see if this here is essentially equivalent to this here. So I need to check my expressions to see if the two are equivalent. So I'm going to do my first one. I'm going to replace the x. So I've got my negative 3, and I'm going to, let me rewrite that. I've got my negative and then parentheses 3. Not writing something correctly, it'll cause big mistakes in the end. And I'm going to replace the x with a 2. So it's going to multiply by 2, and then I'm going to add my 2, and I'm going to end my parentheses, plus 4 times, now I have a 2, so I'm going to replace the x with a 2, plus 2 times 1, and then I can subtract 10. So I can go through and I can start solving this. So this becomes, I'm going to solve what I can in the parentheses first, and then I'm going to distribute my negative. I'm going to get 6 plus 2 is going to give me 8, so I have a negative 8, okay? Plus my 4 times a 2 is going to be 8, and then my 2 times a 1 is going to be 2, and then I'm going to have a minus 10, okay? So I end up essentially with negative 8, and this here is going to become a 0, and my answer is going to be a negative 8, because 8 plus 2 is 10, and 10 minus 10 is 0, okay? So that's where I got my 0 from. All right, so now let's see if negative 8 is the answer that we get when we plug it into this equation. So now I'm going to plug it into this equation here. My x is going to become a 2, my y is going to become a 1, and I'm going to continue that, subtract 12. So I have 2 plus 2, okay, so 2 plus 2 is going to be, so 2 plus 2 minus my 12. And that's going to end up being 4 minus 12, which you can think of as 4 plus a negative 12 as adding the opposite, which leaves me with 8 negatives. So if I had 12 negatives, but I added 4 positives, I have 8 negatives. So we can see that these are equivalent. All right, so now we're going to go through and we're going to write equivalent expressions by simplifying these two things. And we're going to find the sum of the negative 6n plus 3 and 4n minus 9. We're going to take a negative 6n plus 3, and we're going to find the sum, so we're going to add it to 4n minus 9. So I can group my like terms, and then I can break it down and solve it. So that's going to be a negative 2n, negative 6 plus 4, and then this is going to be minus a 6, because the 3 minus 9 is negative 6, right? Here we can do the same thing or the same concept, but what I'm going to do is I'm going to go and I'm going to distribute my negative. So this negative is going to become minus r minus 10 when I distribute it. Okay, so I can look at this and I can go through and solve, and I have, if I regroup, I can do 9 minus 10 plus r minus r. So 9, we can think of this as 9 plus a negative 10, is going to end up giving me a negative 1, and then r minus r is going to end up being 0. If I have an r and I take an r away, I have 0 left, so my answer here is just going to be negative 1. All right, last is this one here. So I'm going to use my distributive property first to distribute this out. So I end up with a negative 10v, and then negative 2 times a negative 1 is going to be a positive 2 plus 7v plus 4. So let's use our properties that we know we can use. I can reorder these, keeping the signs the same. And now I can go through and solve. So I still have a negative 3v, so 10v plus 7v, and then plus 6. So my answer for this one is a negative 3v plus 6. Right, so our last two questions that we're going to look at, a little bit of real-world application of where we're going. Joa calculates the perimeter of the rectangle below, and he says it is 6 1/4 minus 3. So we're going to explain his error and include the correct expression. So we know to find area, we're going to multiply these two, or perimeter, we're not going to multiply, we're going to add the length of all of our sides. So that means that I have to have, and I'm going to do it down here at the bottom of this page really quickly so I have room. I have 2 6x minus 5, because this side here is also 6x minus 5. And I know that I'm going to add that to 2 1/4 x plus 2, because I have two sides that are equivalent to that. So I'm going to use my distributive property here, and I'm going to get 12x minus 10, and then I'm going to add that to 2 times 1/4, which is going to end up being, so what's a fourth of 2 would be 1/4 x, or sorry, 1/2 x. And then I'm going to end up with 2 times 2, which is going to be plus 4. All right, so let's see what we end up coming up with when we go through this. And let's see if we can figure out maybe what the mistake was that happened here. All right, so if I do 12x plus 1/2 x, I get 12.5 x. Okay, and if I do, so I combine this one with this one, and then negative 10 plus 4 is going to give me a negative 6. So if this is the correct answer right here, and Jonah's answer was the 6 1/4 minus 3, if we can compare from here to here, ours is 2 times greater. So to me, that means that Jonah just added these sides together, and he forgot to make sure that he multiplied them from 2. So Jonah's mistake was that Jonah forgot to multiply the sides by 2. And we multiplied the sides by 2 because this side is 1/4 x plus 2, and this side, just because it's not marked, we can't forget to add this side into, and the same for the other. Okay, so, and the correct answer for this one was 12.5 x minus 6. All right, so if we look at this one, we're going to write a simplified expression for the perimeter of this triangle. So if we look at this example right here, we're going to take 1 8/10 x minus 7, and we're going to add, so when we find perimeter, we add the length of the sides, 1 8/10 x minus 7, and then we're going to add 3 4 tenths x minus 3. So I'm going to go ahead and I am going to combine like terms by reordering so that it becomes, oh, I gotta remember that whole 3.4x. It becomes easier to see how they work. So then I have a minus 7, minus 7, minus 3. Okay. So as I end up combining these, and I do my math out, these end up combining right here to being 7x. And then if I have a negative 7 and or I combine it, however, a negative 7 and a negative 3 is going to make negative 10. And a negative 10 plus another negative 7 is going to give me a negative 17. So this right here would represent the perimeter of this rectangle. Right, that's today's lesson. Head on over and work on your practice problems. And please reach out if you have any questions or you need help.